Okay, so today we're just going to review what we learned yesterday, all those vocab words with the degree and naming things like polynomials, trinomial, binomial, monomial. Okay, so in our first term, okay, we want to name the degree. Can anybody remind me what we're looking at when we're naming the degree? Yes? The exponents. So when I talk about the degree, I'm asking you to look at the exponent. Oopsie. My notes just shut down. Okay, so we look at this to find the degree. Okay, kind of looking at the exponent. So here, this has, the x has an exponent of 1, the y has an exponent of 2. So the degree is 1 plus 2, which is 3. So my degree of this polynomial is 3. Any questions on how I got that? Yes. The 2, we don't worry about, that doesn't have an exponent in this case. We only look at the variables and what the exponents on the variables are. That's how a degree is determined, by the exponents on the variables. Okay, then we look at one term. It's one thing there, just one term. What do we call it when it's one term? A monomial, very good. One term is monomial. Does that make sense? Okay, let's try the next one. Okay, when we have multiple terms of a polynomial, we still only look for the one term that has the highest degree. Okay, so in that, which term has the highest degree? The 6xy, the negative 3x, or the y? Very good, the 6xy. So when we're talking about the degree, we only look at the one with the highest degree. In this case, it's the 6xy. The x and y both have 1 as the exponent. So it's 1 plus 1, which gives me a degree of 2. Yes? So yes, so technically x and y have an exponent of 1. Okay, so it does have an exponent even though it's not written in there. Okay, when you're looking at it, since there's 2 variables there, you know it's going to have a higher degree than, say, the ones with just 1 variable. Any questions over that? Then we look back at our notes, and there are 3 terms. What do we call something with 3 terms? Very good, a trinomial. Okay, I just want to have you guys practice one more time. So we're going to just write this in over here. Please tell me the degree and what this is called. Okay, so what was our degree? Where's Nick at? Nick. Okay, what was the degree? What was it? 2. And which term had the highest degree? Very good. So remember that y has a 1. So would the degree be? Very good. So the degree is 3. The 2 and the 1 becomes 3. Okay, then we want to know what to call it. What did you call it? A polynomial. Anything more than 3 terms is a polynomial. Any questions over that? Okay. Okay. Now we talked about standard form yesterday. Okay, and standard form, can somebody read the definition that's on those notes at the very bottom for me? Go for it. Standard form? Very good. So we're looking for the highest degree term goes first. Okay, so if we look here, okay, our highest degree is the exponent of 3. So negative 3x cubed goes first. Then we go the next. 6x squared is next because it has the highest degree. And then finally, the 7 has a degree of 0 because it's a constant, so it goes at the end. Make sure you take the signs with you. So the 3 is negative, the 6 is positive, the 7 is positive, and then that's in standard form. In your homework tonight, if you don't write your answers in standard form, it'll mark you wrong. Okay, so make sure that you're writing your answers in standard form. Okay, you guys do the next one. Yes? Are we ever going to learn to solve these? We will be solving later. Right now, we're just combining and adding and subtracting, multiplying. This year, we're going to focus on quadratics, which is a squared variable. Next year, you'll learn cubics, which is a cubed, and 4th degrees. Come on, pen. Decide to write. There we go. So this should be negative 8y squared. The 2y is a positive 2y, and the 3 is negative. Okay. Any questions over that? Okay. Now we're going to add and subtract monomials. Okay, we're just combining like terms here. Okay, remember like terms have the same variable and the same exponent. And you can only combine like terms. I like to color coordinate mine. So you want to write it in standard form, so you're always looking for the highest degree first. Okay, in this case, we have the 4x squared and the negative x squared. So 4x squared and negative x squared, they have the same variable, same exponent, so they are like terms. This is like a negative 1 in front. So 4 and negative 1 is 3x squared. They're opposite signs, so you subtract. The next one is the negative 3x and the positive 3x. They are like terms because they have the same variable and the same exponent. They're opposite signs, so I subtract, and 3 minus 3 is 0. So I don't have anything. I could write a 0x, but I don't need it there. Because I could also say, oh, there's 0 y's as well. So once the term cancels out or becomes 0, you don't need to write it. Okay, now let's review. Nyla, what is the degree of this now? 2. And what do we call it when there's one term? A monomial. Very good. Okay. Our next one. Do the same thing. We're going to combine our like terms. So 7y cubed is the highest degree. So I'm going to start there. And 5y cubed, those are like terms. So 7 and 5, they are the same sign. So I add them and get 12y cubed. Then y is the next highest degree. And 2y goes with that. So negative 3y and negative 2y, they are the same sign. So I'm going to add them again and get negative 5y. The 7 is all by itself. There's no other like terms. So just bring down the plus 7. Yes?
For the 7 by cubed and by taking the add those. Okay.
When do we add exponents?
No.
Class, when do we add the exponents? When we're multiplying them, okay? In this, I'm just counting. I just think of it as I have 7 y to the 3rd pieces of paper. I have a piece of paper with y to the 3rd written on it, and then there's 7 of them. Then over here, there's 5 of them written on a piece of paper, y cubed 5 times, okay? Altogether, there's 12 y cubes. It doesn't magically turn into y to the 6th. The paper all has y cubed, so it stays. We just are counting them, so you don't do anything with the exponents. Okay, now, Juliana, where are you at? Okay, what's the degree?
3rd degree.
Okay, and what do we call it?
The
Trinomial, 3 terms trinomial. Any questions over that? Okay, I'd like you to answer this question. Why is it important to combine like terms and rewrite the polynomial in standard form before determining the name and number of terms of the polynomial? Okay, why was that important? Answer that question for me. Okay, why did we think it was important to simplify first? It might be easier to look at to find the degree because they're in order now. What else? Yeah. Very good. So if you notice this, in our A, there was 4 terms before I combined like terms. Once I combined like terms, it went down to 1. So it would have been named differently. This is truly a monomial. Okay. If I hadn't combined like terms, I wouldn't have been able to tell that. I would have said it's a polynomial. Okay. So you want to simplify it down to the smallest number of terms it could possibly be before you name it. And then once you've put it in standard form, you have that first, the highest degree first. So it's easy to identify as the degree. So something like that you should have written. Okay, on the back or next page. Okay, now we're going to be adding and subtracting polynomials. Okay, it's the same idea. You just want to identify if you're adding or subtracting. So in this case, it's easy to see. There's a plus sign in between the 2 parentheses. There's a plus sign in between the 2 parentheses. You are adding. Adding is easy. All you have to do is add like terms or combine like terms. Okay, so I go look for like terms. I start again, we want it in standard form, so we're going to put the highest degree first. So 3x squared is my highest degree. Nothing else has an x squared, so I just write it down, 3x squared. The next highest degree is the x, so I have a 2x and negative x. They are like terms. Okay, they're the same exponent and same variable. Okay, they're opposite signs, so I'm going to subtract them, and I'm going to get a positive x, or 1x. And finally, the 9 is all by itself, so I just do plus 9. Any questions over that? We're all good? Okay, do B on your own. Plus 8x. That'd be our solution. Any questions of that? Most of us got it. We're good. I helped a few of us figure it out. Okay, next one, now we're subtracting. You can tell we're subtracting because in the middle, there's a subtraction sign. So we're going to subtract. Subtraction is slightly different than adding. Okay, so our first step we need to do this time is distribute the negative. Because of that negative sign in front of the parenthesis, there's like a -1 right out front. In order to eliminate it, we distribute that negative to our parenthesis. We're just using the distributor property here. So negative times a negative x makes that positive x. And -1 times a +4 makes that -4. So now that's in my second parenthesis. There's a plus sign here now because I distributed the negative. The first polynomial does not change at all because there's not a -1 in front of it. So it stays 3x squared plus 4x plus 2. Now you just combine like terms. Now it's just like an addition problem, and we combine our like terms. So 3x squared is my leading term because it has the highest degree. There's no other x squareds, so you just write it, 3x squared. The next highest degree is 4x. So 4x, there's another x over here. So 4 and 1, they're both positive. So I add them and get 5 x's. Again, there's like that 1 in front of that x. Finally, the 2 and the -4, they are opposite signs. So I'm going to subtract and get -2. So that is my answer. 3x squared plus 5x minus 2. Any questions over that? Okay, I'm going to have you guys do the next one. Okay, you have to distribute that 1 first. It becomes -4x squared and a -6 plus -5x minus 6. So you should get -4x squared, -5x. Okay, this is where we went wrong. This is a -6 and a -6. Same signs you add, and they keep their sign. So it should be a -12. That's the mistake I saw most. I had a lot of people with just -4x squared and -5x. Okay, so fix your answers. Make sure you know how to do that. Okay. Next problem, we're going to not do this number 6. We're going to do something a little different. So just cross out the words and write this in. Find the perimeter. Okay, can someone remind me what perimeter is? Yes. Okay, all the sides, all the way around the figure. Okay, so perimeter, just to remember, add all sides. It's if I walked all the way around the rectangle. How far did I go? So that means I have x plus 8 plus x minus 7. But I also need this x plus 8, which is that side. And then this x minus 7. Now I can combine all my like terms. Okay, so I have x plus x plus x plus x. There's 1, 2, 3, 4 of them. There are 4 x's. Then I have 8 and negative 7. That's a negative 1. Not a negative, a positive 1, right? Then I have 8 and negative 7 here. And again, that's another positive 1. So together that becomes positive 2. So my perimeter is 4x plus 2. Any questions over that? Okay, I do want to review because I get this wrong answer quite frequently. So let's review. X plus x plus x plus x. When I'm adding a bunch of things together, I'm just counting them. I have 4 x's. Oftentimes, you guys give me x times x times x times x. I get a lot of people saying it's x to the 4th. Okay, so notice the difference. When I add a bunch of x's together, I get a coefficient of 4. There are 4 x's here. When I'm multiplying x a bunch of times, I get the exponents because that's what exponents are, repeated multiplication. Okay. So please, on your homework and in your quizzes, 4x plus 2. That should be our answer. Any questions over that?